Okay, thanks for joining. My name is Jamie Knowles. I am product director for ER Studio. Today we're going to be talking about the meaning of life, ontologies, data models, and semantic guardrails for AI. So, title there. If you're a Douglas Adams fan, you'll know the answer to the question. The meaning of life is 42. Now, we all laugh about this because we know it's wrong. But what happens when AI confidently gives us the wrong answer to a business question? That's not funny. People make decisions based on the outputs from AI. So today I'm going to be talking through about why enterprise meaning has become one of the most important problems in modern data architecture. We're going to look at how we used to design enterprise data, why analytics and AI have caused us to drift away from those foundations. We're going to look at the difference between semantic layers and ontologies, and why I believe that the enterprise logical data model is evolving into something much bigger, the semantic backbone that connects governance, analytics, data products, and AI. So let's get going. So we're going to start off with how we traditionally use data architecture, because I don't think we've forgotten on how to model data. I think we've forgotten why we model it. So this slide here is showing sort of enterprise data architecture in the center, and the bubbles on the outside are sort of use cases of what we use data architecture for. So traditionally, a lot of you have been building a lot of on-premise bespoke applications. Each of those applications needs a database, so you'll be designing the database using data modeling, using reusable patterns, so you've got consistency across those systems, which then supports things like application integration. So the messages that flow between those systems becomes a lot easier. Data governance becomes easier if we can use our enterprise models to understand what is the information of the organization, and use that as a framework for our governance. All of our systems that we've designed using this approach can help us build data catalogs. We use our enterprise data architecture for business transformation projects, so maybe a mergers and acquisitions project. We've got two companies we've got to bring together. Let's understand sort of what the pieces mean, and how we can bring it all together. Application portfolio rationalization. Great. So we've got multiple systems. How do we combine them together? How do we combine the data? Okay. Other things like master data management, data virtualization, all important uses of enterprise data architecture. And then the last one, of course, is data warehouse design. So we want to combine all the data from our different systems into one place and provide a body of knowledge that is business driven, that can allow us to answer business questions. So data architecture and enterprise data architecture has been around a long time, and it delivers a lot of value. I've had lots of questions on the sort of the approach to designing things and the need for architecture. Used a lot of analogies like, I'm trying to build a house. Do we just sort of get a good builder and we start piling up bricks and make a great house? Yep, that can sometimes work, but there's a lot of risk. How are you going to sort of guarantee that you deliver against those requirements? How are we going to sort of provide a controlled approach? So this is the approach that we use with data modeling, and how we do it in ER Studio. We start off with some requirements from our stakeholders. It might be that those requirements aren't particularly well written. It might be that we've misunderstood those requirements, but we create these logical data models using business language independent of technology and the implementation, to try and frame those requirements. And we'll go back to the stakeholder. Is this what you were looking for? No, it's not. Just go again, and we'll iterate on the logical model until we get it right. We've got a business friendly picture that allows anybody, any business stakeholders, to be able to understand what those requirements are. Once we've got the requirements and we all agree, we can sign off on that. And then we can, from that logical model, generate a physical blueprint that's aligned with the technology, applying things like naming standards. So we might have a relational database, it might be a JSON structure, whatever it is. And again, we can iterate on that, adding in things that are unique to the physical implementation in that technical blueprint. And once we've got that right, we sign off again, and then we can generate code from it. And then we iterate around again, new requirements. Okay, let's look at how that affects the logical model. change the logical model. Again, go back to the business stakeholder. Is this what you're looking for? Yes, it is. Get sign off. Move those changes to the physical model. Again, more iterations, compare the physical model with a live database and generate the appropriate code to make the changes. So we've got a very controlled change process here, where we can ensure that the requirements from our stakeholders are well understood and make sure we've done that before we actually sort of build anything. Okay. Now, something that we're very keen with EL Studio is the notion of reusable architectural patterns. So that design process will go through and say, okay, the requirements talk about a thing called client. Now you'll see here, we've got this notion of an enterprise model. If we go to the next slide, sort of building up this enterprise model, we might go through sort of stages of a high level conceptual model where we go through and we look at the different domains of the organization, sales and marketing and products. We'll work out what are the things that sales and marketing is interested in and owns. Notion of ownership is really important. So customers and orders, product management own things like products. Great. So we've roughed it out. And then we can add more detail, again, using the same domains, creating more detailed models. So customer, actually, there's different types of a customer. And here's the differences between those different types of customers. And customers place orders, and orders have order lines. And this is how we identify a customer. And these are all the main sort of properties of a customer. So this enterprise model is really important. So when we go back through, let's whiz back to this model here. So the requirements talk about the notion of client. Okay, so we'll look in our enterprise model. Is there anything that looks like client in our enterprise model? Yeah, there's customer. Then there's different subtypes of a customer. Crikey, the requirements didn't mention what type. Let me go back to the stakeholder. This project's talking about a B2C customer. So we can reuse, we can copy those entities into our model, which means that we've then got consistency across all our designs. If we're building different systems, great, all the systems are talking about customers and important information in the same way. It means that interoperability is easier. Our users understand how to use the product easier. We're building a data warehouse, great. We understand how the business talks about customers, so we can build our warehouse that is aligned with the business. Okay, so these enterprise models are really, really important. In our studio, we can build them and we can link them together and we can sort of navigate through the models. Okay, but it really is a model of how the business works. It's not a technical thing. It's how does this business operate? And that's the sort of the hardest part of what we do as data architects is really trying to understand how the business works, working with those business subject matter experts and stakeholders. We can use the enterprise model then to understand and design our data assets. So if we're designing a system, we'll go through the process, as we said, create a logical model from it, then create a physical model. There's a relational database. We'll do the same thing for JSON structures. We take that same logical model, EL Studio will render it into a physical model for our JSON structures. If we're documenting a COTS package, we could perhaps reverse engineer it, create the physical model, and then generate a logical model from it in business language. And then we can start mapping it to our standard definitions. So this system talks about the notion of client. That actually means B2C customer in our enterprise model in our standard definitions. So it's a great way of documenting things. It allows us to create a data catalog. Some data catalogs might also incorporate the notion of a business glossary in there. Okay, so we can create a whole series of business terms and get the governance folk confirming those terms, then start going through the process of classifying terms, assigning policies and rules to those pieces of information. And those terms all then attach to our enterprise logical model, our framework. Okay, but that's the basic core of a data catalog, which allows me to ask questions on where is information on a particular piece of information or topic. So credit rating score, where do we store credit rating score? It's in these systems here. Or we can perhaps go to a particular system. Okay, this table's called cust has got a column called cred_scr. What does that mean? Okay, it's mapped to a business term, or it's mapped up to my logical model. I understand what it means. So that's the core of using our enterprise model to design and document any type of data asset, whether it be a database underpinning a system, a file exchange between systems, or maybe the data warehouse. But what we're finding in practice is many organizations in the real world haven't been using this sort of approach for data warehouse design so much. And we see a sort of lots of images like this with lots of sort of little bubbles showing technology and things. Generally, a lot of data warehousing projects are really focused on creating pipelines as quickly as possible. They're focused on using technology and tools across more domains. It's all about speed. We want to deliver at speed. And customers now are starting to use AI more. Can AI help with this? Can AI start to interpret all of this data? And this is where things really start falling down with our AI. So projects optimized for delivery, architecture really became sort of the architecture of the implementation and the technology. And what we're forgetting about is the notion of business meaning, really being able to understand how does this business work in terms of its knowledge and its information. A lot of the sort of meanings assigned after the fact. We'll build the warehouse first, we'll get the developers creating code, smashing out structures in the warehouse and pipelines, and then we'll come along afterwards, after the fact, we'll apply documentation, we'll attach meaning to the tables and columns, we'll do governance after the fact as well, so it's reactive rather than designed. A lot of organizations are using star schemas rather than those sort of enterprise models, those business models. It's all about speed rather than architecture. And this has worked fine for a good few years. But the problem is, again, AI. And we're going to talk about why this falls down next. Okay. So semantic drift is something that we've been talking about a lot. So I'm going to take you through a little example here of why it's important to understand the meaning of information. So the scenario is one of our stakeholders comes along and says, great, get me the revenue figures for all of our customers. Okay, it's a perfectly good question. So we go and look at our different source systems and identify which source system is going to give us the information to tell us about the revenue of our customers. Great, we build a warehouse. Might apply a medallion architectural pattern to it. We created our bronze, silver, and gold layers. We've got some star schemas containing all that information. We then can connect our BI tool to it. We can connect Copilot to it and ask both of those tools the answer to our question. And great, everything's integrated. This should work. Instant answers. Power BI comes along and tells us, yes, 120 million. And then Copilot says 147 million. Okay, we've got different answers, and potentially both of these are wrong. And this is a common challenge. So how do we address this, and why is this a problem? So let's look at the question that we've been given. Get me the revenue figures for all of our customers. So the first thing is, well, customer itself. What do you mean by a customer? And this is a big question. Seems like a simple one. What do you mean by a customer? Well, first of all, there's different types of customers, B2C and B2B. And then how do you define it? Is it build to, sold to, end user? And then you've got the status, the location. Gosh, what is a customer? I've spoken to customers out there, some of our customers, and they've said, yeah, we spent a project on this. It took us a year talking about what is the definition of a customer, going across different departments. We just couldn't agree. And we never actually managed to achieve what is the definition of a customer. Okay, that's a problem. So if we don't know what a customer is, how can we answer the question, get me the revenue figures for all of our customers? We've then got revenue on itself. So what do you mean by revenue? Do you mean booked revenue, billed revenue, recognized cash? What point in time? So how do we define what is revenue? Then it gets worse. You might actually find that, yeah, we know what booked revenue is for a B2C customer, but the calculation that we use for a B2C customer is different to the booked revenue calculation for a B2B customer. Gosh, okay. So this is going to cause us a problem. And I think it's fine when human beings are trying to work through this problem. Okay, this stakeholder has asked me this particular question. I'm going to think about it, think about the systems. I'm going to build all the pipelines all the way through, and I'm going to get the answer to the question that I understand. Where it all falls down is when we connect AI. If the AI isn't absolutely sure what these definitions mean, we've got implied meaning, we're going to get the wrong answer. This is going to give us a big risk. Okay, so how can we harden up what these things mean? data models. So in this model here on the screen, we can see that we've got the notion of a customer. Customers have invoices and customers place orders. This clearly shows us that there are different types of customer there. We've got a B2B customer, B2C. We can apply definitions to all of these things. We can apply useful information on how do we identify a customer, how do I identify the different types of customer. I might identify a B2C customer in a different way to a B2B customer. Yeah, we've got a customer number across everything, but you can also identify a B2C customer with their first name, surname, and postcode, for instance. But then we get to our revenue attributes, and you can see here that we've actually got our different types of revenue all laid out clearly in the model. So a B2B customer has booked and billed revenue, and that's a fundamentally different attribute to the booked and the billed revenue for a B2C customer. So against each of these individual unique attributes, we can provide a definition for them. What do we mean by them? Potentially, we can also add in things like how do we calculate them? How do we define these metrics? Something we're looking at in ER Studio is a way to define metrics at this sort of level to say, yes, the booked revenue for a B2B customer is the invoice value times 34 plus this, etc. So we can lay out those calculations. But what we want to be able to do is have one model for the organization where we can understand how does this business define what is a customer, what are the different types of customers, what the differences between them, and then all the different characteristics, attributes, calculated fields, lay them all out, uniquely name them, provide the definitions, and make sure that we've got a clear understanding, an explicit set of definitions for the meanings of these things. Okay, a slide here that I quite like to use, sort of the value of architecture. This was created by a chap called Martin Fowler some years ago. He's really talking about some system design. There's two lines on here. The brown line is showing sort of, yeah, if we build something without architecture, we can start off very, very rapidly. And then over time, as we start adding in more and more functionality to a system, then the overall output gets slower over time. If we start off with a well-architected system, we start slower, but then we've got a nice, more linear, sort of a more steeper curve. We can add functionality sort of quicker over time. And I think this applies to both systems and things like a data warehouse or databases. You can see there's a sort of an overlap here. At some point in time, then the architected approach overtakes the lower architected approach. And Martin Fowler was saying sort of this point occurs in weeks, not months. And I think the same thing for a data warehouse. A lot of organizations are building data warehouses with minimal architecture, starting off quickly, all about speed. But I think as things get more complex, we're adding in more data, we slow down, and it's sort of law of diminishing returns. All right, so the warehouse itself, so how do we use our enterprise model? And this fairly scary looking diagram kind of explains it. So here we've got source data assets that we've created using our logical models, perhaps from the enterprise model, mapped into the enterprise model. Great. As we're designing the data warehouse, we'll come on to data products later on, but we might start designing the different layers. We might start off understanding the requirements, creating a logical model for it, translating that logical model into implementation models like a star schema. The different layers of the warehouse, the silver layer, if we're using a well-defined Inman architecture, we're going to have a silver layer that's well harmonized, driven by the business. So we're using the definitions in our enterprise logical model to drive those different layers. We've got consistency across them, and everything is attached to that one set of business meaning. Okay, so again, we can go anywhere in the warehouse architecture and say, well, what does this column or table mean? It's mapped back to these set of standard definitions in the center in our enterprise logical model. I mentioned data as a product. I've got a couple of slides that sort of talk through data as a product. Originated from the notion of data mesh. We want to treat the outputs of our warehouse as a valuable asset, not just something that nobody really cares about. Every output of our data platform is going to be treated as a product that has value. It has rules, terms and conditions. Okay, we want to be self-serve. So different domain teams around the organization want to split our organization down into domains of subject matter experts. Those subject matter experts are going to define what are the products that the rest of the organization wants from our domain. We want those subject matter experts to be able to drive the process of developing products. So it's a great approach, and I really like it that it's assigning that value to a valuable resource, which is data. The approach that organizations take is kind of this. So there's our different domains, the green vertical bars. Each domain will build some sort of governance framework, perhaps centered around a business glossary. The domain will then conceive their data products. Okay, and then eventually those data products will be realized as physical assets. It might be a star schema, it might be an API or a streaming service, or it might be multiples. Okay, something that we've been talking about a lot, different data governance tools that are handling data products like Calibra, for instance, are really pushing for the notion of contracts around those data products. Something we've been doing with Microsoft Purview is extending Purview to include the notion of a contract. So the approach is we've conceived the notion of a product within that domain. We've got some basic requirements. We then want to harden up that data product and provide a contract for it. So anybody should be able to see, what am I going to get with this data product? What information is going to be provided within it, alongside the terms and conditions and the rules and the policies around that data product. So we've got a contract that defines all of that. For what you're going to get in the products, we advocate the use of a logical data model, something that is business friendly. Anybody should be able to come along and say, yes, in this data product, these are the pieces of information that we're going to get. And then from that logical model, we can realize that into one or more physical models, one or more implementations of that data product, all bound by the same contracts. You're getting the same information, but it's realized in different ways. Okay. And again, the logical model, we can, through that process that we talked about earlier on, where we start off with a logical model, we get sign off on that. As we're creating the logical model, we're reusing components from the enterprise data model. So we've got consistency. So this is a really important thing when we're defining the products within a domain. How much consistency do we want? Is it okay that within a domain, the notion of a piece of information is different across every data product? Or would we like consistency? Do we want consistency across domains? This is a really important question that everybody should ask when they're building a data as a product approach. How important is consistency in this? When we're talking about the notion of customer, is it important that every domain uses the same definition of customer? And the other thing is, when an AI is consuming these data products, does the AI understand what is the data in these products? So are we providing the AI with well-defined definitions of these? Okay, now the point I want to make here is that data as a product without shared meaning creates semantic silos. And so without that discussion on consistency, we're going to have problems. So data as a product, that whole approach is intended to be decentralized. Each domain is kind of independent. That's absolutely fine. We can do that. But having some sort of centralized set of definitions so there is consistency is a really important thing, especially if AI is going to be involved. So going back to our model that we were looking at earlier on. So here we've got our data product contracts. Again, same sort of process. So the conception process is someone creates some requirements, we'll create the logical model for that data product, reusing entities from the enterprise logical model. We can then use that logical model, that contract, to then refactor it into our star schemas to understand where our source data assets are coming from, that's going to feed those star schemas, to be able to design and ensure that the silver layer is well architected to be able to provide that information. Okay, and then everything's connected to our governance foundation. Okay, so we keep talking about, I keep talking about AI. This is kind of the new world of analytics. So in the past, the BI tool has been the sort of the primary output of the data warehouse. We'll create human built reports and dashboards. Modern BI tools will be driven by things like natural language queries. The AI will be able to sort of navigate its way around that data and come up with sort of its own signals on that data and insights on that data. So Power BI and a lot of the other BI tools have got the same sort of approach. A lot of our customers are now connecting general purpose AIs to their data warehouses. So again, they can go in and ask natural language queries. Now, the AI in both of these tools has got two missions. The first one is to understand when you type in a natural language query, what does the question mean? They've given me a question. What is the revenue of our customers? What does customer mean? What do they mean by customer? What do they mean by revenue? And the next part is, well, I've got access to all of this data in the warehouse. What does this data mean? And how does that data connect to the question I've been presented with? So that's the challenge that our AI is being faced with. So the big thing that everybody seems to be talking about at the moment is the notion of semantics, which helps us address both of these two questions. So semantic models are big at the moment. The notion of ontologies is becoming increasingly popular. What is an ontology? So at its core, an ontology is a formal structured representation of a domain. Great, okay, that makes sense. It's going to contain concepts. Okay, each of those concepts has a definition and some properties. All right, that makes sense. Those concepts are connected. We're going to have relationships between them. Okay, that makes sense. We're going to have hierarchies and be able to classify those concepts together to form taxonomies. Okay, and we want to be able to render them in machine readable formats. Now, to me, those first 4 points seem to be exactly what we try and do with our data models. Okay, let's hold that thought. Being able to render them into machine readable formats. So there are multiple formats out there that different tools can ingest as semantic models, semantic layers. Okay, we'll hold that thought. Semantic layers is a term that's popular as well. So we're seeing a lot of different tools allow you to provide a semantic layer. So BI tools allow you to create a semantic layer, which describes the meaning of the information that BI tool has access to. Looking at those semantic layers, are they well-structured ontologies? No, generally it tends to be just a sort of a markup of the physical model of whatever the BI tool has access to, along with some logical names and some descriptions. So it's not really a sort of a well-structured meaning model, an ontology. It's just some sort of useful markup. Likewise, ETL tools like DBT allows you to create semantic layers of the different layers of the warehouse that it has access to be able to create pipelines. Again, those semantic layers just tend to be markup of the data. It's logical names and descriptions of these things. The database platforms, so we're seeing in Snowflake, Databricks, etc. They've got semantic layers. They've got catalogs within them. Again, it's just sort of metadata. So Snowflake, for instance, allows you to provide descriptions of tables and columns. It allows you to attach tags to those things. So it's allowing you to attach meaning to the physical data. But again, it's really just markup. It's sort of just logical names and descriptions. Going back to our original sort of question of give me the revenue for our customers, we saw that you need that structured model, that sort of taxonomy to say, okay, we've got a thing called customer. These are the different types of customers. These are the different types of revenue and the calculations for them. So we need that structured model. The semantic layers of these different tools is not really enough to explicitly define the meaning of our data. So that's where, so yeah, it's very much implementation specific. So those ontologies are really important. Okay, that's that notion of concepts and the relationships, the taxonomies, etc. There are different options for building these ontologies. This is something we're seeing. So the notion of a knowledge graph. There's a lot of tools like Microsoft Fabric ontologies. There's tools out there like Protégé that allow you to define a knowledge graph with exactly what we've got on the screen. We've got sort of concepts related together. We've got different taxonomies. A knowledge graph generally has two different layers. We've got our organizing principles, so different types of things, and that's called the T box or terminology box. And then the actual data is down here at the bottom in the assertion box. So we've kind of got, to me, the data model and then the actual data attached to it. So that's an overarching knowledge graph. This is the sort of thing that an AI will natively produce. Other ontologies out there, we've got the business glossary. So a lot of business glossaries, ideally you'd create a whole series of business terms, but rather than just having them in a flat list, you're going to arrange them into some sort of ontological model, showing taxonomies, attaching business terms to different concepts. This generally doesn't happen. Generally, we see business glossaries as just flat list of terms. So I might have a business term that just has revenue against it, and I might have some description that says, yes, here's the definition of revenue and the different types of revenue. It lacks the structure that we're really looking for our ontology. Okay. The enterprise data model is an ontology. So as we said, we've got concepts, relationships, taxonomies. The enterprise data model is the perfect vehicle to be able to convey an ontology. Okay. So, and we've also got lots of extra information in there that is really useful, as well as just conveying the concepts and the properties of them. We've got lots of useful information for how does the business identify these things. Every type of customer can be identified by its customer identifier, but B2C customers can be identified by first name, surname, and postcode. Great, useful stuff. All of this is really useful to drive our AI. So one of the challenges that we've got is that we end up building multiple ontologies in organization. We've got our data governance team that are defining the information of the organization and the meaning of that information, creating their ontology. We've got our analytics team using the AI tools to generate these knowledge graphs, which has got the ontology of the organization. And then we've also potentially got the enterprise model as well. At this point, we've got three different ontologies with three different sets of definitions. This is dangerous. So ideally, we want to have one set of definitions. We don't want this semantic entropy to occur, this semantic drift. So the approach that we're trying to advocate with ER Studio is this. We use our enterprise logical model as the core ontology of the organization. We can then use that to drive the other areas. So data governance, we can actually harvest sets of business terms and attach those terms to that enterprise logical model. Tools like Calibra advocate the notion of guided data stewardship, where that governance framework, instead of being centered around a business glossary, is actually centered around an enterprise logical model. That can come from ER Studio. ER Studio can synchronize with Calibra. We can use the enterprise model to design our layers of the warehouse. Here we've designed the gold layer of the warehouse using that enterprise logical model. So all of the definitions of these tables in our star schemas, all of the definitions of the columns in our star schemas will originate from the enterprise logical model. From these physical layers, and you'll see this in the next release of ER Studio, we can now generate semantic layers for our different products. So we can generate things like TMDL files and Power BI projects that drives Power BI. We can generate open semantic interchange files to provide a semantic layer to other BI tools. We can now generate DBT labs files to provide the semantic layer for our ETL tools. So we've got many different semantic layers for all of our different platforms, including the database itself, all coming from ER Studio, from the same set of definitions that we've provided in this very well structured enterprise logical model. Where we've got a general purpose AI, again in the next release of ER Studio 21.1, we're going to be generating RDF structures. So we can render that enterprise logical model into the top part of our knowledge graph, those organizing principles, that T box. So we can generate the RDF file with the concepts and their relationships, their properties, and the taxonomies. We're also enhancing that RDF to include things like shackle constraints. So how do I identify all of these different things, that useful information in the business glossary? We're also including SCOS linkages to say, hey, this node, this thing called customer here, here's all the business terms in our data governance tool that give you the policies and rules and maybe the sort of definitions provided in the data governance tool. So we can give all that as a package to the AI. The AI now understands the meaning of the information, how the ontology of the organization works. So again, when you ask the question to Copilot and say, hey, tell me the revenue of our customers, it understands what is a customer and what is revenue. It can understand, because of these semantic layers, where that attaches in our physical models. So using this approach, we're going to have a better chance of success. So the sort of thing we're advocating is this. So the enterprise logical model forms that semantic backbone. So all the different semantic layers of our different platforms and products, our databases, our BI tools, our AI, all those semantic layers are being generated from that enterprise logical model. Our data governance program is centered around that same semantic backbone, that same ontology, that same meaning model. Okay, we're generating business glossaries, we're helping form the data catalog, we're defining our data products, all using those same standard definitions in that enterprise logical model, that semantic backbone. Okay, so I think we're starting to get to the end. We're going to summarize now. So the enterprise semantic backbone, we're going to define meaning once, and we're going to reuse it everywhere else. So every downstream implementation uses those same set of definitions. We're getting rid of semantic entropy. No matter where we go, we'd be using the same sets of definitions. Okay, we're aligning our data products, our semantic layers, all those implementations of that meaning model, okay, against the same set of definitions. Our AI is then going to be using those same set of definitions so that we can trust the output of our AI. So the summary is: enterprise meaning defined once, realized consistently everywhere. So this whole approach, we've created some white papers. I've been working with Bill Inman, that you might know. We did a webinar fairly recently with Bill. We've written a white paper that talks about the notion of a semantic backbone to drive AI data platforms. If you scan this QR code here, it'll take you to our website where you can download that white paper. Bill and I have been working on a little book of rules of thumb. So it's just a sort of a list of different sort of rules of thumb for different parts of the process of building an AI program and grounding it in enterprise meaning. All right, let's go to questions then. So I'm just going to look through some of the questions here from you guys. Right. So surely AI will just become smart enough to figure all this out. I think that is a fallacy and dangerous statement to make. I think the AI cannot assume what this organization means. One of the things that we've seen is the definitions drift across an organization or across organizations in general. Most AIs are trained on a sort of global set of definitions, but different organizations will have different meanings for different things. Different organizations define customer or revenue in a different way. Even gets down to the point of different parts of an organization, different departments defining things in different ways. So we see finance defining revenue in a different way to sales, in a different way to another part of the organization. That might work fine when human beings are very clear on what set of definitions they're using, but when we've got an AI looking across the whole organization, that it could be absolute disaster. That's that semantic entropy problem. So I think we've got to have one human curated set of definitions across the whole organization. Maybe different departments have different terms that they use, but we can attach all of those synonyms to our enterprise backbone so that the AI has a fighting chance of being able to understand that question. When someone types in what is the revenue of our customers, maybe the AI can come back and say, okay, what definition of customer do you want? These are the definitions I've got. These are the definitions of revenue. Can you be more specific? So we've got to get to that point. The AI can't do that on its own. So we've got to have a human curated set of definitions that we can give to the AI. Yeah, I see many blending the documenting of the what of business data with the how of enabling it. The how is using the same content of metadata but using a different technique term. Example, is an attribute the same as a property in an object? Um, Again, we're seeing different parts of the organization using different techniques to build out that meaning model. We've got the business terms in the business glossaries. We've got our group of ontologists working in products like Protégé, which are quite difficult tools to use. I think, yeah, we can definitely harmonize what do we mean by an ontology and what we mean by a different model across the organization. But the main thing is that we are all working together on one set of definitions. Hopefully I answered that question. So the questions here, like, so will the recording be available? Yep, we're definitely going to be sending out the recording afterwards. Along with the PowerPoint itself. All right, other questions, what have we got? If you choose one place to define what a customer revenue or product means, would you choose the business glossary, the semantic layer, ontology? Okay, that was asked earlier on, or the enterprise logical model. So again, I think this is the danger that a lot of organizations are doing. They're defining it multiple times in multiple places. That's giving us that semantic entropy. And what we're advocating is having one place where we define that meaning, and then a tool like ER Studio can then generate those semantic layers for all those different purposes. We're sharing those same definitions. If every domain builds its own data products independently, what guarantees that customer revenue still mean the same thing across the enterprise? No guarantee. And again, one of the things, I think the idea of data as a product is incredibly valuable, but the danger is this sort of siloed approach, this sort of separated domains all working independently. I think that can work fine on the implementation. Maybe each domain does have its own individual data warehouse. That's absolutely fine. Maybe they have their own set of definitions, but they have to be connected through some harmonizing mechanism so they're sharing meaning across those different domains. I think again that notion of a semantic backbone will do that. Aren't data models too technical for business people to use to model the business? And I think that this is a challenge that so we're facing as a data modeling tool. The logical data model itself has been designed for that purpose. It's again going back to that first slide. We take the requirements from a stakeholder, we draw a pretty picture that anybody should be able to understand. That pretty picture has got enough rigor and robustness in there to be able to provide precision to the definitions of the information. It's designed for that purpose. Within ER Studio, we're looking at different ways of sort of rendering those models to make it sort of more business friendly, make the tool more business friendly to get business users involved. But yeah, I think the logical data model as a science, as a construct, is absolutely perfect for this, for defining an ontology. I'm really keen to hear from any of you guys out there that are looking at building ontologies. I'm having some good discussions with ontologists. Is an ontology the same as an enterprise logical model? Is an ontology, is this something we could derive from an enterprise logical model? At the moment, the answer to that question is yes. And as I said, in the next release of ER Studio, we've got the ability to generate good, solid RDF from those models that you can open in tools like Protégé. Then AI can natively understand, and you can ask questions to the AI. Okay. Yeah, interesting question here. Should we be spending more effort improving the AI or improving the meaning of the data that we're giving it? I think hopefully that what we've just been talking through is good enough. AI models are going to get better and better, but they still have to be steered on what does this organization mean by these different terms? What does it all mean? All right. I was aiming for 45 minutes. We are bang on time. I think we're out of questions. If you are interested in talking more about this topic, there's again another QR code on the screen. Scan that and get in touch with us. We'd love to talk to you more. We can give demonstrations of a lot of this stuff. Thank you very much for listening.